Paul here, and today on the bench I have this industrial waffle iron. Customer sent it in, said it's not getting hot. This one here weighs about, I would say, 10 to 15 pounds, each half. I pulled the rod out so I could separate this box, which is the control box, which has the cord and conduit going to each side. They each have a heating element in them. And like I said, this is like a steel block. These things are heavy. Unreal. I think it would make waffles just from the weight of itself. I don't think it would need any heat. But of course it does. I'm just being silly. So I took the rod out so I could separate this box. This has the heating control, which you can see. And it has a NSF certification sticker, a light, and a switch to turn it on. I'm assuming it's 110 volts. I'm sure it is, yes. But the cord is 16.3 type SJT 300 volts. So this thing draws some power. I can't just plug it into my Variac because it isn't going to work. I don't know what the wattage rating is on this. It doesn't say. Doesn't say what it's supposed to draw. It doesn't seem to have any model numbers. Perhaps on the back of one of these things, it's a OCOR, Ocory, or something like that. Let me see if this one says anything. Same thing, Corey. Doesn't seem to have any model number or description or anything like that. So this rod here goes through these two connectors here and through there. So this sits like in the back. Actually, yeah, sits like this, but from the other side, so it's all one unit. Okay, anyway, we're about to open it up and take a gander inside and do some measurings and see what we can find. This thing is huge, so I'm going to set the camera overhead where you guys can see, and we'll see what's inside this thing. This ought to be fun. Incredible industrial waffle iron. Be right back. Okay, I'll try to keep all of this in the picture for you. I know these are out of the picture right now, but we're going to start with this. And once we finish this, then I'll move that over so you can see that as well. But let's start by taking this panel off and see what we got going on in there. Now this is a high wattage device. I'm thinking the problem's going to be in the waffle iron and not this control box, but you never know, and the best way to start is from one side or the other. And since it's easier to start with the line cord, we'll start with the line cord and we'll work our way through each of these devices. Since he said the customer said it was not heating up, I'm thinking it could be in this control panel, because what are the odds of both heating elements going out at the same time? Pretty slim, right? Unless one was working and it was working at half efficiency for a while, and then the other, finally it went out. But we'll find that out. Let me get something to keep this clean. We got quite a bit of stuff to clean up as we go, and I'll clean all this before I send it back. Okay, let me get another paper going here. In a minute. Okay, there's the control, and this is the heating elements here. So I don't know, that could be just an asbestos covering or some kind of covering that goes over the heating element. And there's the inside of the cover, so it's got some grease got into there. This was this way, so it came in from this connector here. But we will clean that out. And yeah, It looks like OCOR, Ocory 6401. So that may be our model number. We'll set this here. Set our little magnetic dish for these screws so they don't get lost. Okay, let me get another hand cleaning paper towel so that as we go along I can keep from making a mess. Paper towel with some alcohol basically to keep it. Okay, we have a strain relief here, which is not reaching. Okay, it does reach the case there. So I'll leave it there. And we have a ground coming in here that's connecting to both heating elements. So both heating elements have a ground, a hot, and a neutral. And yeah, I'm seeing it looks like a brown wire, a blue wire. Actually, it looks like a pair of blue wires. Okay, there's a, yeah, it looks like there's a pair of blue. No, they go over there. Where does this one go? Goes over there too. Okay, so they have a yellow wire, a brown wire, and a green wire going to each heating element. There's a control rheostat here, which is probably a culprit, but I'm not sure. There's an on and off switch and a light. Let's start with the basic thing. We're going to take some continuity test on the cord. We'll check the cord first, make sure we get signal through. Of course, it's still in circuit, so yeah, but that won't matter. It'll either be connected through or it won't, right? Put these cables on this side. It's a new meter I bought, X-Tech. My other meter that I really liked, this moose tool, has gone dead on me. I'm going to try to fix it. It's still lighting up and showing numbers, but when you go to measure, it jumps all over the place. So it's probably something in the inputs going through. But I had it apart. I just don't have time to work on it, on my own stuff, so I just bought another meter. And this has got a better reputation and all, but I prefer the other one so far. It's heavier. This is lighter. Anyway, go ahead and try to get this on sound. You should hear that now. Okay, good. Take these retainer caps off here. Protection caps. Okay, let's start with the plug. So here's the plug. And I'm going to put this on the ground. Let's start with the ground connection. And if I can get into that cap, we'll know. There's a cap here. I guess you can see that. Okay, so the ground's good. So now we'll try the hot wire. Sorry, the neutral wire. I had it backwards this morning. Okay, so the neutral is this white wire, which is going to here. Okay, the neutral is fine. Now we'll check the hot wire. Hot wire is the black wire coming in, and it's fine. So the line cord is okay, which I kind of figured it would be, but we wanted to rule it out. Actually, one of the last devices I worked on, the line cord was actually bad. And it was a nice line cord, but it was open. And that was just weird because it was like one of those computer line cords, a very thick, heavy-duty line cord. I don't know if you can see that meter, but I guess it really don't matter. You can hear it. All right, so we know the line cord's working. So the next thing is we're going to check the switch. The switch appears to be a double pole, double throw switch. So let's put it in that position, and we're going to check. Yeah. Just a little more over so you can see it better. Here's the switch. and it's a double pole, double throw switch. So we're going to check the probably what is the on connection. It's on both ways, right? It's on and on. It's a double pole. Okay, we get nothing there. Okay, it's going this way even though the switch is the other way. Okay, so the switch is working there. Let's check the other terminal. It's working. Now we'll flip it the other way, and this should be off, and this should be on. And that's on, and this should be off, and this one should be on. I can get in there. So let's disconnect this wire, which is the easiest to get to, and that's going to be both of those go together, but we already checked the ground. I'm not going to worry about the ground. It's going to be this one. Of course, it's the whole kit and caboodle, right? Dang, it's on there. Come on out of there. Tools are stuck underneath that device. That's so heavy I can't pick up my tools. Okay, that ain't coming out of there. See if we can get any of them off. Oh, that one's off. I need to get them off because I need to have them individually accessible so they're not bleeding through each other. Ah, okay, so that one was, okay, I see how that is. All right, so they got multiple tabs going on here. All right, this is the wires from here, and that one goes to the light. And the other wire we need from here, I'm probably not going to be able to get to, is the switch wire, but we got it disconnected, so it really don't matter. And it goes to the center input wire, so we'll just use this and connect to that. Okay, but this is an individual wire, totally separated from all the other wires, so we can do a continuity check or resistance check from this one. Okay, we have resistance. We got 28 ohms across the heating element in this unit here. And this one here. We got 28 ohms across the heating element. 28.2. Let's try the other heating element. The other heating element is this one that goes through the other side. And we got 28.5 ohms there. So we have continuity, and that's a good thing. Well, actually, hold on a second. Does that go to the same place? I believe it does. I believe those two connect together. Yeah, they go to the same place. Okay, so we have continuity through both heating elements, which is good. That kind of suggests to me that these heating elements are working, because 28 ohms is a low current, right? If we are drawing 115 volts across 28 ohms, well, figure 25 ohms would be 4 amps, right? Be almost 5 amps. So a little over 4 amps of current times 120 volts, you're going to be around 500 watts. And that's probably about right. That will go up as they get hot because there's a temperature coefficient, right? So I'm still thinking this control is going to be a problem unit. It has a temperature coefficient of 80 to 200, looks like 220 degrees Fahrenheit, so actually I'm wrong. That may be, yeah, maybe 200. It looks like a 7. I would say 720. So 80 degrees to 720 degrees Celsius is the range of this thermostat here. Let's see if we can get that out of there. Well, hold on a second. Let's see what else we got. We got a black wire that goes to the switch. So the switch turns the power on to this heating unit, which turns the juice on to these and also to that light. So what I'm going to do is connect it back together and plug it into my outlet and verify that these are indeed not getting warm. I'll put one here where you can see it. Okay, and we'll verify that they're indeed not getting warm. I'm sure they're not, because that's what the customer said, but you know, we want to check and know what we're doing as we go along. So this goes back in there, that goes back in there. And that whole unit connects back on here. Okay. And we'll see if the light works and all that good stuff. So I need to find a plug to put this in. How about that one? Okay. Let's take a look at how this goes. All right, that's all the way counterclockwise. I'm going to turn it on. It's on. So this is a on, off, on switch. And I'm just going to leave it all the way down for now and see if either one of these is getting warm. This one appears to be heating up. This one's heating up. This is working. Okay, I'm going to shut this off. That's strange that has a double click. I don't know exactly why they would have a two-way switch. What I'm going to do is I'm going to plug this into the cord and plug it in and monitor the current and the wattage, and we're going to see what kind of current and wattage we're getting out of this device. I can get it in there somehow. I'll take some of these out to make room for it. Okay, my voltage is 122.4, so I'm going to turn this back on. The voltage dropped to 120.8, that's normal, so current's flowing. We are drawing 8.51 amps, which is 1,029 watts. So we got 1,029 watts going to this is hot. This is hot. This one's really hot. This one's getting that. Yeah, it's hot too. Okay, so what is the problem? Now, what does it do if I put the switch the other way? Nothing. There's no current draw on that. There's no current draw on a halfway. It's only when it's up and the light's on. So I don't know why they have a double pull, double throw with two wires on the side. Oh, that's disconnected. Okay. Just happened that that's the switch they had to use. It's rated at 15 amps, 125 volts. So it'll draw up to 15 amps, which it's in the proper range. We are drawing, again, 8.59 on my mains. So now I'm really confused. I need to find out from the owner if this unit is not shutting off, if that's the problem, because it is turning on. Actually, let me do one more test, and I'm just telling you what I'm doing so you'll know. You really can't see. But what I'm going to do is turn it on, check the current draw, and I'm going to turn this knob and see if it has any effect. It shouldn't, because this basically controls this. And this registers the temperature from the unit from one side, and when it gets to a certain temperature, it shuts off this control. When the temperature drops on the waffle iron, this temperature on this wire drops. This is a temperature gauge. It drops, and when it drops, it turns the unit back on. Now, you wouldn't know that by the light, because the light would be on all the time, but you'd know it by the current draw. So we're going to check that. So right now we're drawing 8.57 amps of current. And I'm going to turn this joker up. I obviously can't let these things get red hot. Okay, no, see, that has no effect at all on that. And that would make sense. Turn it fast, has no effect on it. And that would make sense because it needs to get hot, right, before it shuts off. It's to keep these at a certain temperature so they don't burn the waffles, basically. We'll shut that off. These jokers are warm. I'm going to have to let them cool off. And I'll clean this all out because it really needs to be cleaned out to protect these components. But I'm not seeing any problem with this device yet. No, unless there's something I don't know. So I'm going to check with the owner and see exactly what this device is doing wrong, and then I'll be back. Okay, I talked with the owner, and what he said was, and this is still quite warm. In fact, let me put something under there to keep it as much as possible off of the plastic here. It's not melted it so far because I didn't really get that hot. But what he said is that it heats up. It was heating up and working fine. It's obviously quite vintage. And then all of a sudden it started where it wasn't getting as hot. And then it got to the point where it wasn't heating at all. So what I wanted to do is check in these units while it's cooling off a little and see if any of the connections just need to be cleaned. Obviously like I said, this could be asbestos. If it's not, it's some other heat protecting element to protect the wires. And you see they kind of like just sit. This is interesting device here. I would imagine this is that the one that has the wire going through it. Yeah. No. So this is not the one with the heating unit, thermostat rather. It has a metal plate here that this connects to, and then it has a heating coil here, which is underneath, and you can't seem to get that out. Maybe if I take that screw off, I can get it out. But you see, this has gotten pretty hot. These wires also, too, seem to have some kind of protective heat insulation on it. It is cracked, but not bad. It's actually in really good shape. This one got a little bit black here, so there was some heat draw through here. And these wires are connected in here, and I can see that one. These two are a little loose. Basically, there's a screw that tightens down on this side of this heating element and this black wire. This is the other side of the heating element. Actually, they do move. So, what I want, and I don't like the fact that that whole thing is loose. You'd think they would have bound that up somehow. But what I want to do is take the wires off and clean them a little bit and put them back in so that I know they're making good connection. And then, of course, before I put the cover back on, I'll go ahead and clean some of this out of here, just to keep it from causing problems. That bubble there. But, and that's a protective heat pad here and here. It's got a little hot on this side. You see where it's been heated there. And just a lot of stuff to clean off another tray. But I'll get all that clean before I reassemble it. I'm more concerned right now with electrical. So when you're working on something like this, especially free floating like this, you definitely want to secure what you're doing. And if these things got hot, you're not going to be able to unscrew them. This one, unfortunately, unscrewed. They would be welded. They're getting so hot. Okay, it has a connector on the end of the wire that's factory installed, so I'm not going to deal with stripping the wire or anything like that. You can't solder this because it's heat. So you have to clean them off. The first thing I'm going to do is just wipe it down with some alcohol and get any residue off that'll come off, including the wire itself. It's looking pretty good. Yeah, it's looking pretty good. This rag, I've been using it. It's just very little, but you definitely, this is like cupped. I don't know if you can see that, but it's sort of like cupped like this, and the screw goes down in the center of it. Okay, so that's how it goes. So when you're working on a control like that, look at how they are when you take them out. If it's just a round wire with a screw going in it, you understand. But this one is cupped this way, and the screw goes in the center of the cup. So when I put it back in, I need to make sure it's that way, not like this, not like this, not like that, but like that. The helping hands. Okay, but what I want to do is, since it's so black, and this is probably why it hasn't been getting so hot, is I want to clean that off a little. And the only thing I can use that's safe to do that would be a piece of like emery cloth or something like that. Something just to get the tarnish off the wire, the corrosion off the wire, without actually hurting the element. See how it's cleaning it out? I don't want to break it off. I don't want to cut it off. I don't want to sand it down to nothing. That metal needs to be there, but it needs to make good connection. Now, we know when we started, the resistance was 28 ohms, I believe it was. This should increase the off resistance, just the dead resistance of this connection and this heating element by a percentage, right? Cleaning this should definitely help. Now, it probably makes connection on both sides, so I'm going to clean the back too. I'm sure it does, actually, because the screw pushes it down onto something. And I can see it's pretty clear there where it was making some kind of contact. You see I'm getting that stuff, tarnish and grease and grime off of there, but I'm not hurting the connector, and that's the most important thing. You don't want to hurt the connector, you don't want to hurt the wire. And the wire's been hot many times, so it's stiff. So these are things you got to take into account when you're working on vintage devices, especially devices like this that are getting hot and cold, that, you know, that takes its toll on everything, right? See how that's cleaning up? And I'm not pushing hard, I'm just getting this issue taken care of, this corrosion or whatever. I'm going to try a little contact cleaner. I don't know that that'll help it, but it won't hurt it. Not too much. It looks a whole lot better. I wish there was a way I could get inside here, but this, I think this side is just where it's got like two ridges. This side is just where the screw pushes it down, so I don't think this really has any electrical issue on this side as far as connectivity. This is just where it pushes down to make this side make contact. So, and I cleaned it up some too, so that's better. And then I'm not going to put it, it goes back in there and you tighten the screw, but I'm not going to do that just yet. The heating element on this one is here, and the heating element on this one is here, so I'm just going to deal with I can get the wires out and deal with the wires first. Amazingly, this is a pretty good system, because normally heating elements weld themselves to the contacts that connect it to, and that may be the case with this one, it's not coming out. And when that happens, usually there's nothing you can do, because they get welded together and you can't get them apart. Well, this one finally came out, and that looks more like brass there. Again, it's just corrosion. The wire is very stiff, so I don't want to force it trying to turn it. This is very mild, it's not abrasive at all, because you don't want to, if there is a finish on the metal, you know, like some kind of electroplating, you don't want to take it off. But this one doesn't seem to have that. It seems to be just a metal plate that's crimped on a metal connector. And I probably, even if I had to, if one of them was broken, I could probably crimp a metal connector on there, and it'd probably be fine just with any metal connector. But to be safe, I'm trying to keep it all original and clean it out manually. Okay, that looks pretty good. Looks pretty good. Let's try a little more alcohol. I'm going to get a clean rag. Paper towel rather. I'm going to wipe it down a little, get any grease off, and try to get in that groove some. Again, see? Again, that groove is just where it pushes down. That's why I keep my fingernails long. They come in handy for stuff like that, the tools. Kind of embarrassing out in public, right? Having long fingernails, but they serve me well. Look at that, nice. That's much nicer. Those are both in much better shape. They should make good contact. Okay, so they go like that, and I'm just going to bend them like that. And I really don't want to take the heating elements out, but let's try one of them. Let's try this one, it's easiest to get to. Oop, get the screw completely out. Didn't want to do that. Put it back in. Okay. Take that one out. Yeah. That
one, it actually makes a connection on the top side. It's different shape, different connector. It would make sense that it's different because it's a heating element made by some company. And that I got to be really careful. I don't want to break that off. And that looks actually really well. I figured those would probably be fine because that's not where the power is coming in. It's the actual heating element. So I'm just going to put that guy right back in there and check the other one if I can. Okay, he's nice and tight. No, he's not. The screw's nice and tight. And again, that's probably because that screw came all the way out and I didn't get it. Okay, came all the way out again. Get that back in there. And that's why I don't want to take that heating element out of here. I think we got a problem with this one. Let's see what's going on here. It's slid up in the insulation. Okay. Maybe lift that back up with the screw. Or not. I got it. Yep, that's good. Okay, I'm going to tighten that a little bit tighter. I want to make sure I had a good grip on it, and I do. So those two things are completely connected together. That one wasn't bad. I don't really like the idea of taking this one off because it's going to be a pain to get in there. You know what? I don't think I'm going to. I think I'm going to check the resistance because it looks like these were the issue. So let's get this back in there. Okay. Okay, let's see if that changed the resistance on this one here. Have to disconnect that again. And it may not, because the resistance on these changes as they heat up. And so the initial resistance, the cold resistance, really doesn't mean a lot. But if there is a bad connection, the cold resistance would mean something. So let's see if we get a better reading on that. And that would be, again, I use these connectors here. That goes to that one in there. Okay. And do I have a red wire on this? No. Yeah. I want to duplicate what I did so I have the same resistance, but actually these are soldered, they have no real issue. Okay, so it does zero out, okay. .28 ohms. So yeah, that's what I figured. The cold resistance is not going to be much difference because what little bit of resistance those connectors would have at a low temperature, at a low ohms, is going to be, you know, it might be, it's like 28.1, it might have been 28.4, you know, it's going to be a very small percentage. However, as the unit gets hot, the resistance goes up, and the percentage of issue would be amplified accordingly, and actually beyond, because they're not making good contact. So we got these in there, and that seems good. Answer this. Okay. Yeah, I don't think I'm going to take this one out because this one wasn't bad. The heating elements, you know, they're designed by a company that makes heating elements, and they're designed a certain way. Wires, on the other hand, are made by cable companies. They're not, you know, they are what they are. So anyway, these were definitely corroded. That wasn't so bad. This one goes right into the heating element, straight down. If I take this off and I can't get it back on, then I'm in a mess. I'll monitor it and see what the temperature is, and if it's a major problem, then we may have to revisit that. But for right now, I'm judging by what I've seen here. I'm going to assume that that's at least in the same ballpark, in which case we should be fine. So now that we got this one done, I'm going to go ahead and, well, I want to check that too. We'll do that next, actually. Let me plug this all back together. I'm also going to clean these contacts in here in this control box, but right now I think they're doing okay. So I'm just gonna, they look very clean and everything's clean in there. Aluminum is, you know, you can spray it down. I want to check this connection here. I hate taking this off, but I really do want to check that one because that one is, again, a wire, right? So let's see if we can do that without a problem. I'm hoping there's some kind of connection on the bottom that isn't going to let go. Okay, so far so good. Actually, I'm going to put a drop of oil on that, just so that that nut doesn't cause any undue pressure on the shaft. So you've got tight again there. There is some buildup on that shaft, and I don't want it to cause a problem. There's a little bit of pressure. It got some stuff in the grooves, but the threads of the nut cleaned it out pretty good. I can see it oozing out there with the oil. And that's what the oil does. Now, had I not put oil on there, that thing could have bound up. And if I put pressure, if you're doing something like this and you put pressure and it's bound up, you'll break the shaft free, and then who knows what's under there to get it tight again. And just the nut itself, look. So that's what came out from the oil. So using oil is a good way to get the threads in the nut to dig into the threads on the shaft and get all that grease and grime out of it. And then, of course, you can wipe them off a little bit, too. Okay, because all of that is definitely an issue. Now, you can see that this needs some cleaning just like the other wires did. And that, I could crimp another one on there, but I'd rather not. Because, again, it may not make as good contact as it is here. Inside here, it looks nasty on the outside, but inside there's a copper wire that's crimped in there, and this is not, you know, they don't make anything like they did back then. Even these eye loops, I got brand new eye loops, but, you know, can they handle the heat as well? I don't know. And so using the original, if you can save it, you know it works. You know, the actual down here where the wire is not the issue. It's just this ring and the nut. You see that's cleaning up pretty good. Spray a little contact cleaner on there. This stuff dissolves instantly, so it won't hurt none. You see how fast it dissolves? Evaporates. But it does get corrosion and break it down. Okay, let's take a look at this cap. Curiosity light. Oh boy, see what? I didn't want to break that free. See all that stuff in there that's dried up? See that? That is something. This is steel, so I can clean this. In fact, I can use sandpaper to clean this. But that's why I said I didn't want to break anything free. You see all that corrosion in there? And I'll show you in a second what I'm seeing. I might put this on a wire brush and clean this up so that it makes good contact. Okay. I can clean that up and get that off. And shine that right up on my wire brush. Okay, but this. Get a piece of it out of there. See that? That's what's left of the heating element insulator that's around this shaft. That's why you don't want to put pressure on something like that, because that's holding the shaft in place. And if that shaft breaks, it's also insulating it from this metal plate. But if that shaft breaks, because this is all deteriorated, you can't replace that. There's no way to get this unit. So I just want to make sure that the teat in this screw are clean. So I'm going to put some more oil a few times until I know it's making really good contact. In fact, while it's sitting here, let it dissolve some of this. Let that work in there, and we'll get that nice and clean. And then this is what it makes contact with against this metal plate. And it digs in. You can see nice shiny metal here. It digs in when you tighten that nut down on this edge. So it's not going to be an issue. In fact, that feels very sharp all the way around. It's designed that way so that when you tighten the nut, this turns a little bit and it cuts in and makes really good contact. But we want the nut and the wire to make good contact on this top edge, and that looks pretty good actually. Let me pull that a little bit more. See, it's pretty clean on the top. So the nut drives that connector on that, and that's what cut this groove in here that you see. By the way, that's still warm. That thing holds some heat. It's not hot, it's just warm. All right, this is this one. So I'm going to set this aside, and we're going to do the same process with this one here. Take a look at it and see what it looks like. So I'm just going to set that there where it's nice and safe. This needs to be cleaned, so we'll put it with the other things that need to be cleaned. And we don't need that no more. This is no longer hot. It's just warm. So turn this around, and we'll try this one. And that's stainless steel. So I can clean that up pretty good too. Now this is why it doesn't look as happy as that last wire we did. This is frayed here and levels a little bit, and this one is extra crispy. So you gotta be careful with those. Let me clean this a little bit. All right, let me get alcohol. I'll clean them before I reassemble. Oh, let's try this wire. This one's. Can you see that okay? Yeah, yeah. That's all right. See that screw moving when I move this wire? So some of them have been welding together. That's because it's not letting go of the connector. Got it. And yeah, this joker got hot. This one got hot. See how like glass colored it's looking? Like so it's like copper colored. And the wire is very stiff and brittle. Here's the heating element, which we need to clean it too if we can get it off there. I don't know how that disconnects, but if we can clean that off, that'll help too, because that's what, this is a temperature gauge. Oh yeah, that's just that. It looks definitely loaded. That's much better. Look at the difference. That's better. Okay. And we're going to gently put him back where he was. We're not going to deal much with him. Got it in there. When tightening those, you don't want to over tighten them, but you don't want them loose either. If they're loose, they're not going to have, they're going to get hot, and they get hot because you're welded. But at the same time, if you tighten them too much, you could strip them out. This is just porcelain with an insert in it. You can pull the insert right out, let it insert, the screw goes in. Same thing, it doesn't always go as well with the other side of the contact. The screw's out already. Okay. He's still, this side had some issues. Let's see. I don't know. May not be able to get that one out. Maybe I'll luck on that one. Get it out. Let's just spray some cleaner in there. One second, I'm trying again, but I don't think it's going to come out. I think it's welded together. The advantage of it being welded together is it's a good connection. The bad side is you can never replace it. You can never get them separate. It's no longer two pieces, it's one piece. I'm going to get a little noisy here. So far in, all I'm grabbing is on is the wire. I can't grab the actual connector. Put more pressure. No, it's not coming out. The whole contact inside is moving, so there's nothing we can do with that one. It should be, it's nice and shiny in there. I don't know if you can see that, but inside there it is nice and shiny. So, and like I said, it's welded together, so there really isn't nothing I can do with that. These are clean screws. They're hot, they've gotten hot, but they're not a problem. All they do is push two pieces of metal together. Okay, so that's fine. That's the best I can do there. Yeah, it's got hot. See how fried that is? I can't unstraighten it. Like this. See how it was originally? See how flexible it is? This is like rock. So this one got hot, and it's been a problem here. That's why it welded there. This seems fine. We can try to take that one out. Just a curiosity to see if it'll come out okay. Yeah, and look at it, looks really good. They did a good job. I know it's kind of like glass. So yeah, that's fine. There's nothing I need to do to that.
Make sure it's in there. Yep. Okay. Now we'll take this off. Again, this has gotten hot too. I can feel it, the build up. Go a little slow here. Because we already know what's underneath it. Not bad. Oh yeah, that's good. It's gonna get tight at this point. It's just coming off easier than the other one did. Alright. I'll clean these better before I put them in. I'm going to run a Q-tip in there with some clean them off. Alright, there's that one. It's not bad. Get the oil off of it. It's not bad. And what I'm doing is I'm holding the base of the connector here. I'm not holding the wire, because if you did that, bending it back and forth on that wire, it could just come right off. Hold the connector, and you can clean that really well. Okay. See, you didn't have to go that. It's a whole lot better. Looks good. Okay, take this guy off. And look at the difference. This one, the actual insulator is still intact. It didn't swell up and come out. That's probably why it
Unscrewed. There's a piece of it there, though. See? Probably why it came off easier. And this one might not have gotten as hot as the other one because this connectors took all the heat. And for this to get hot like that, that goes back to what I was saying. If the connections are loose, if they're not tight enough or they're not making a good enough contact, they're going to get hot because that's going to be a resistance area. And so this got all hot, and this wire got hot, and this got hot, and this welded itself, it got so hot. And so the amount of energy going into the heating element was less because it was being consumed here. Okay, does that make sense? That's why connections have to be clean, solid, so that the energy is going the way you want it, the wattage, right? You don't want it going, being absorbed into the heater and just heating up the wire like the wire is some kind of power resistor. It's not supposed to be a resistor. It's supposed to be a nice solid connection. Now the current, the ohms on this line was 28 ohms too. So the cold resistance doesn't really tell you much because this is a heating element. It's designed to get hot. And as it gets hot, the temperature coefficient changes. And the heating element, it's like a filament in a light bulb, right? When you first turn it on, the resistance is low. So the energy draw when you first turn on a light bulb, an incandescent bulb, is really high. It draws a lot of current initially until the filament heats up and turns white hot, which draws the light, right? And when the filament is hot, then it's a resistor. Its resistance goes way up. Well, it's the same thing with heating elements. They start out as almost a dead short, big power drain on your fuse circuit breaker, but it's only for a short couple milliseconds. So your circuit breaker doesn't usually trip because unless it's something seriously worse than that, because the resistance goes up fast with the heat coefficient change, and once the resistance goes up, the current goes down, and your circuit breaker is happy again before it has a chance to trip. Okay, I'm going to clean this one because you can see. And I'm going to clean this one. I'm going to clean these both on the wire brush and make them shiny as I can get them. They are coated, so, but that ain't gonna matter. That's not gonna matter. This coating is so old, it's not an issue anymore. Continuity is more important than the condition of these metal plates, and these are steel. They're gonna last forever. But the fact that they're not all that black in there on the inside, around here, and here, and around this edge, all of that affects the amount of current going through the circuit, because you see this one doesn't have the cuts into the plate that the other one has a little bit right there, you know.
So, and I can't do much with that, right? So I've got to make this where it's strong enough to really get into there and make a good connection, like I was showing with this one. It does have a sharp edge, but it didn't do anything here, which is probably indication that it wasn't tight enough. And again, you got to be careful. You don't want to over tighten them because they can fall apart. I see another flaky piece in there. Let's get it out. Okay. Don't want any junk in there that's going to interfere with the connection. Okay. This here is grease, but it's old grease. It's not coming off, so it's not a problem. This is the thermostat here, and it's inside of a half connector, so I can't really get it out of there. I don't think. Oh, wait a second. Maybe I can. I notice this plate's moving. And the whole thing's moving. This insulator and all, I don't want to take all that out of there. If I could get that out, I could clean it. Yeah. I would have to get this out in order to get that out. I don't like doing that. This is so close to, I got it. Yeah, what a mess that is. This, not making good conduit connection to this metal plate here, having all this crud on it, is going to heat up, shut the thermostat off at the wrong temperatures. So we definitely want to clean that. Now you can't use anything abrasive on that. It's not going to be shiny, but we can get the loose junk off of it. And you got to be very careful with this. You don't want to kink this. If you kink it, it's not going to work. But we want to get as much of this old slimy junk off here as we can. It's not really slimy, it's dried up. It looks wet, but it's not wet. It's just probably wet when it gets hot. So we want to get that off because that has to do with the thermostat. You can hear it, right? It's dried up on there. You can see it too. Right here's a big buildup. And this is just paper towel with alcohol. It's not abrasive at all. That's the original color there. One I do. Okay, now here we can't do much with this. I can probably run a Q-tip through there and get some of that out of there. Most what I use is inert, like alcohol. Not worried about the outside, I'm just worried about the inside there. I wish I would quit dropping down. How to get it back up? Oh, that's right. Well, I'll be. Okay, well that's interesting. I would like to get this whole heating element out of here, but with the cord it ain't gonna happen. Stand up and try to get in here a little better. If I could get the screwdriver underneath it. There. Lift that middle up. Yeah, got it. All right, I got that side. Ah! Sorry. Get some alcohol on the other side. Try that again. Got it again. That's relatively clean in there. This is just grease. It's not like this build-up stuff that's really hard. It comes right off, which is nice because it's hard to get in there. One more try. This time with a dry one. That out. Pretty shiny now, pretty clean in there. Think so, less and less. That's good. Now I can put that back in there. Drop it back down. It'll make much better connection on that heating pad. Okay. I mean, that's freestanding, but there is radiate heat between the metal plate and the shaft. In fact, when I do get this up and running, I use the same kind of device on my meter. These are heating elements here. See, it's got a little knob there, and it just measures the change in resistance in the wire as it gets hot, and the meter tells you how much heat there is. Here's a different one. Oh, that's a probe, but this is another heating element. This is the one that came with my new meter. So we will check and see what kind of temperature this thing puts out, but I got to get it on
surface there where it can get hot and stay until it cools off. And these plates, I can use oven cleaner on those, just like, right, like a regular oven, right? So I'll take them in and clean them and get them hot and clean them off with some oven cleaner or something. I don't want to sand them, just want to clean them. This rod, same thing, I'll get it cleaned off, get this gunk off. Now that I can do on a wire brush, that's just a hinge pin, so that it'll be easier to open and close. And it's got build up here, right? This is where it turns, and this is where it just hold, right? Just normal, right? Gets hot, gets cold, gets hot, gets cold. Okay. Now, put that in there. My magnet thing so I don't lose them. Okay, that's pretty much it. At this point I'm going to shut the camera off. I'm just going to clean this stuff and I'll show it to you. It's not going to be much different than it is, except the loose stuff will be gone and whatever's build up I'll knock down. I can't really do anything in these other than get the worst of it out. The rest of it I can clean up and I'll show you those once they're cleaned. This box has got a lot of crud in here, see all that? In green, it's copper corrosion there, and all this. And there's a bunch up here. See all that? But that's a plastic case, so I'll go ahead and clean that. If I could get the knob off, I could really clean this good. Okay, get the knob off and pull the cables out, but I'd rather not pull those out. But I'll clean it out. You know, it's time consuming, right? And that's where the labor cost is the amount of time it takes to do this stuff. That's, of course, I never charge all my time anyway, but I don't, because I do videos and I take time to teach you how to do this stuff. But it's still, you know, there's a basic amount of time. And anyhow, let me clean it and I'll be back. Okay, I took these metal plates out. They come out pretty easy. I'm going to go ahead and clean up this side here that goes down on this heat resistant pad, which is probably asbestos. This one here came out too, but had a lump of stuff there. It's got a lump of stuff here. This one was deteriorating under here, and over here it's cracked. This is the one that got really hot. So I'm going to go ahead and clean this one off on my brush and get this out so we know it's not a problem. And that's probably asbestos, so I don't want to breathe it. I'll go ahead and get it cleaned off here. I'm just going to scrape it down a little bit. And of course, if I do go over this on my wire brush, I'll wear a mask, because this is probably asbestos, and if it is, I don't want it in my lungs. I don't even like it in my skin. It itches like crazy, and it takes a while for it. See how that's like lumped down there? Takes a while for it to work itself out of your skin. Right. People in California, eat your heart out. And just hear them now screaming at the top of their lungs, "That guy's nuts, he should be in jail or in a mental hospital or who knows where." Okay. You know how many decades of people worked on asbestos siding and asbestos pipes? When we went to school, we had them wrapped around heater pipes in the elementary school. We used to stick our pencils in them and break them off and throw them around. And oh well, it is dangerous. I'm not saying it's not dangerous, but it's not. You don't need to wear NASA clothes to deal with it. I'll be back. Okay, I got the
got these plates cleaned up the best I can. Interesting thing is this stuff here actually ate into the steel. If you can believe that. This one isn't bad. This is the one from here. I'm probably going to put it in there and switch them around so that they have better heat transfer. But this is the one that was in there. And this side is not bad. I cleaned it up an iron brush and got a lot of the junk off. But look at this. It ate right into the metal. That's just unreal. So I'm going to put this one on here with this side facing out. And put this nice good side down on this side here. And I already cleaned these out the best I can. So they're clean. And I'm going to get the wire through there. So that's going to go like that. I cleaned these up. And you remember what they look like. And, well, they look like the center there, right? But, because I couldn't, my brush wouldn't get in there. But you can see they're going to make really good contact. Cleaned all the way around. That can go on there. I got the nuts soaking in some alcohol to get the grease and junk outside of the grooves, and then I'll clean them with some Q-tips to get in there and get all the junk out of the grooves. Same with these. I'll clean these off before I put them on. This is the one that ate into everything and it deteriorated here. You can see rust here where pieces of the metal came right off. It just ate it and rusted it right through there. I'm hoping that this one is not in really bad shape. I don't know. I'll give you an idea what's under here. I don't think I can take it all the way out, but okay. Yeah, maybe I can clean this one. Look at that. And this is the bottom of this plate. So I'm going to go ahead and wipe this down. This just comes off. I'll go ahead and clean that on my brush and now that I got it, I feel a little more confident getting in here. But this is a royal mess, and this is an asbestos covering. So let me take that off. That's what ate into the metal. And this is the heating element itself here. And I'll be very gentle with cleaning it. So I'm just going to set it there. More asbestos here, going in the trash. All right. Let me go ahead and get the loose stuff out. I'll clean that. Since I was able to get them off and clean those plates, I figured I'd show you what was underneath this one as an example of what I've been cleaning. All I'm doing is getting grease out of this. Let me see. Be careful with the wire. There's not much else I can do with this, but just get the worst of this out of here. It'll definitely, it should heat that much better with all this cleaned out. Get a lot out of it, right? Okay. You figure it took, what, 70 years to get in this condition? So, just doing this, I'm adding another 30, 40, 50 years to its life, not counting what it's going to have just being serviced. That's just getting this junk out, because that's going to take a while to come back. Okay, so that's got to go back in. Let me clean this a little bit. I'm just very lightly going over this with alcohol, which is take some of the grease and dirt and stuff off. The asbestos sheet, there's nothing I can do about that. All I can do is put it back in. Oh, let me get this loose stuff out of here. I already scraped the edge of this. I scraped the edge of this around here so the cover will fit a little bit snugger and the rest of this will get through there. You know, it's going to work its way through. Okay, before I put that on, I got to go clean this off. This is copper, so it would make a good connection and get the worst of this off. I'll see how it cleans up on this side here. I don't want to, if it cleans up nice and neat, then I'll brush the whole thing. If not, I won't brush the whole thing. Let's see, I'll go see what that does right now. And I'll be back. Well, that looks a lot better. And I couldn't get in there very well, but that doesn't matter. It doesn't really make contact with anything. It's 100 times better than I expected it to be. And so that'll make much better contact in there. Let's drop this in. This plate back in here. That goes under this metal and makes contact there. All right. Actually, I think I'm going to put this side up because I have a much better contact point there. Are these metals different sizes? Oh, well, yeah, that holds off center. I didn't even recognize that. Okay, here's what it is. And it goes on there, and this goes in here, and there we have it. Much better. Put that back toward the center. All right. Put it in there. I'll go ahead and clean this off a little bit. It's soaking long enough. Put a Q-tip in there. Alcohol. And get that out of there. Take the dry side and get some more. Yeah, that's good. Okay, so that goes in there. I'm thinking this way would be better. Tighten it. I'm going to use these. That's good. It's snug and tight. And that's in there good. And that's making much better contact than it's ever made. So we're good there. Except I forgot to put this back in. Now I got to take it back off. Well, never mind. But yeah, that's going to work. Okay. Let's take this back out. This side. This nasty thing here, this is the asbestos wafer. And, oops, it's deteriorated pretty bad. So there ain't nothing I can do about it. And it's broken. But it's just more or less a heat resisting pad and a spacer. We got it in there. Okay. Put that back down, okay. That's good, we got it back. Put that back in. Okay. Right. Now, put this back on. Oh wait, I put this back in. Put that back down there. There it goes. Push that down. Come on, stay there. Good. That's where we want it. Put this there. Got a nice connection now that I got all the corrosion and stuff off of that metal plate and off this compression washer. Yeah, it's tight. That's really good. Okay, that one's nice. Let's get to this one. These things don't clean up, by the way. I went over them, but they're not going to clean up. So I don't want to force them or break them on you. They're just porcelain, and they really don't matter. It's just a contact. Grate's clean. I didn't pull that one out, the asbestos pad or anything. We might be able to get it out of there. I don't want to force anything. I don't want to move. The other one was so loose that it just came out. Yeah, see, this one's snug. I don't think there's any problem under this one. I got it loose. Sort of. I don't know what those nubs are. I guess it's just the rivets that did that. So, this one is not wanting to come out. This is mica here. Yeah. That's actually not bad. See, the other one was a whole lot worse. There's no alcohol. This one's dry. There's nothing wet under here. But since we got it, we'll clean it. And whatever we can out is a benefit, right? Can't get it all, but whatever we can get out is that much better. And that's how you got it all. like it was like, it's a rock, mineral, but it's like a plastic, you know, as far as its consistency. Yeah, okay, we got that back in. Put this nasty thing, put this back in. Nope. This one does look scented. It's a little bit off center.
Okay, I got the unit back together and back in its case, and I did a check on the element, and both elements are working fine. It gets hot, thermostat shuts off, okay. I did notice that some smoke comes out and it's got a little bit of smell, but that's probably from being opened and cleaned and exposed, you know. That should go away, but I can't guarantee that. All I know is what's there is working and the heat's right. The current draw is right. Draws around 10,020 watts, which is sufficient to get it really hot. I can't touch it. I'm sitting here on a metal box cooling off. But yeah, it got hot. It shut off. I raised the thermostat some more. Came back on, current was the same, wattage was the same, got hotter, shut off again, and so I'm assuming it's functioning as it's supposed to. Like I said, I moved a lot of pads around, did a lot of cleaning in there, so you know, it's kind of like got to settle back into its normal state, but it's working. Anyway, thanks for watching. Hope you found this video interesting. Working on this, looks like Ocory, O-C-O-R-Y, I believe it's Ocory. Not sure, I can't quite tell what that model number is. But you see it's all cleaned and the rod's back in, and there you have it. We never know what we're going to work on around here, but it's fun doing it. So thanks for watching. Please consider giving us a thumbs up, and if you've enjoyed these videos, then please subscribe to the channel. Thank you.